Okay. Good afternoon, everybody. First of all, thank you very much for coming to this session of blockchain. And before starting and introducing and having here fun, I would like to say thank you very much for all of you coming to Israel in this wonderful weather. I'm sure you can do other things, and we were just talking a few minutes ago about the wonderful beaches that we have here in Tel Aviv, in Herzliya. I'm sure it's much more attractive, but at least in the next few hours, we will try to bring you some new stuff about blockchain. And the thing is, over the last years, this blockchain technology was really high in the media, and in some time it was even the from technology perspective, the most searchable word at Google. And we wanted to understand what is behind that. And I think the industry already took it one step forward in two areas. One, in cryptocurrencies, and we saw what happened 2 weeks ago with this announcement of Facebook. And in parallel, they are today in the majority of companies. I don't want to say all because maybe I will miss one or two companies, but majority of companies already have different groups involving in different implementation of blockchain. And the majority of them are trying to do cost saving, much more efficiency, transparency. We think this is just the beginning. We think when blockchain will be the mainstream, where blockchain will be a new turnover of new incomes, not just to make things much more efficient. And this is the direction that we are trying to take this session today, talking about use cases, talking about regulation, and what are the barriers for enterprise and organization to take blockchain to the mainstream. With that in place, what we will do today, we will have a first keynoters from Intel, and then we have 3 panels, and we were encouraging our panelists to give you some hot news, so it will be very interesting. And if we will have time, and this depends on you, we also maybe try to ask a question from the audience to our panelists, so they will be surprised from your questions. So prepare with good questions, and we will try to organize this. I will start with our first speaker today, which is also a close friend. Previously, from my past experience at Intel, he was working with me. And I would like to invite Mr. Anand Pashupathy, he is the General Manager of Security Solution Engineering Division at Intel Architecture's Graphic and Software Group. Anand's responsibilities include setting strategic direction, definition, and delivering capabilities influencing partners both inside and outside of Intel. Anand earned his master's degree in computer science from Arizona State University. He also received his MBA from Kellogg School of Management, Northwest University. So I would like to invite Mr. Anand.
Jacob, thank you for that wonderful introduction. Where did Jacob go? Oh, right there. He's in black. He's hard to see in the crowd. Thank you again for giving me the opportunity. As Jacob said, I run a security solutions team at Intel. And we're not going to have a test at the end of this presentation on Intel's legal disclaimer. You all know Intel as a technology leader, right? We have brought you many innovations like Ethernet standards, the USB standards, and obviously Moore's Law. And we continue to advance our investments in autonomous driving, artificial intelligence, and quantum computing. We are bringing that same, I want to make sure I don't drop this. We're bringing that same energy to blockchain as well. And the whole point of blockchain really is to help enterprises and IT departments to really capitalize on this transformational technology. And the remaining 10 to 12 minutes that I'm going to be on stage, I'm going to primarily talk about or give you a bird's eye view of what Intel is doing in the space of blockchain. Okay? At the end of the day, a very good blockchain is dependent on two major things. The first thing is really a foundation of trust. And the second thing is a scalable consensus mechanism that makes it interesting for enterprises. And I'm looking at it only from an enterprise perspective right now. And in order to deliver this foundation of trust, privacy, security, and scalability are very, very important, along with driving enterprise adoption and really delivering a scalable model for blockchain. Our focus on blockchain is really centered on these three pillars that I show you on this slide: silicon, standards, and software. And I'm going to drill into each one of these. Where do you think I'm going to start? Intel is a silicon company. I'm going to start with silicon. It's foundational to the platform. It's core to the platform. And Intel technologies like Intel SGX and Intel Xeon scalable processors really are solving problems for privacy, security, and scalability, and delivering this foundation of trust. And at the end of the day, it also helps with enterprise deployment or enterprise adoption and blockchain scalability. There are enough studies out there, primarily from Deloitte and Tata Communications, that talk about that blockchain adoption is on the increase. But by the same token, they also, I shouldn't say warn, but they say a huge impediment for blockchain adoption in enterprises is really the transactional throughput. Everybody else in the enterprise really works with very fast transactional system, and on this slide I'm showing you the average transactions per second for some of the leading blockchain ledgers compared to the Visa network that everybody uses for transferring or sending money. The number I want you to focus on is the 1,200 transactions per second that Intel and IBM have really optimized both in hardware and software to deliver on Intel platforms in partnership with IBM for Fabric compared to Fabric 1.0 to where we are right now, which is almost a 6x improvement in performance. Intel also announced the blockchain Intel Select Solution platform that will come out later this year from our OEM partner Lenovo. At the end of the day, transactions are really kind of a baseline requirement. You need things to work really fast. On a particular node, you want the fastest transaction throughput that you can possibly get. But then there are other benefits that also happen because of that. The first one really is you're reducing transactional latency. Things are happening really, really fast. It also gives you the ability to deploy either on-prem or in the cloud with the necessary transaction throughput. And the last thing is the combination of both of these really allowed the network to expand. So it's very important that transaction throughput, whilst it seems really small in terms of transactions running really fast on a node, but there are other benefits for a faster moving or a system with faster throughput. I'm going to talk a little bit about Intel SGX, which is really an architectural extension which gives you the ability, or which gives developers the ability to increase the security of their code and of their data. And it's up to the developers to repartition their application to deploy the critical aspects of their application inside an SGX enclave. And to me, an SGX enclave or SGX really is an application level TE, because this is done in software, and it gives you the benefit of privacy, security, and support scalability. Corda is an enterprise class blockchain infrastructure that also has, that is in the open source community. R3 announced at RSA earlier this year that they will support more secure execution of Java virtual machine bytecode using Intel SGX, okay? And they call this deterministic JVM because it really gives them a level of finality to their transactions and creates that level of determinism. And this work with R3 gives three basic benefits to them, or gives Corda these three benefits. The first one is the ability to encrypt the entire ledger using Intel SGX. The second one is there is finality or determinism associated with the smart contract execution. And the last one is the ability to securely execute within an enclave or between enclaves. This also opens up an area for all the Java virtual machine or Java developers out there, and there are many of them, to write applications based on Intel SGX. I'm going to move from silicon to standards, and the point on standards is we are working with consortia, academia, standards bodies to really facilitate development and ease of deployment either on-prem or in the cloud. And I'm going to give you two specific examples of how this is happening in the ecosystem. You all know cryptography is kind of fundamental to a blockchain running. From the point of that you use hash functions to connect blocks to digital signatures that are used for securely settling transactions. There is no common agreed upon set that developers use. They use their own. There is no sharing capability. There is no enhancement capabilities. So the Hyperledger community looked at this problem and said, wouldn't it be great if the developers had a common agreed upon set of cryptographic libraries, okay? That's what Hyperledger Ursa is all about. It's a set of cryptographic libraries that will enable people and projects to avoid duplicating a work and give you a common set of cryptographic code. The advantage of that is you can now apply hardware optimizations to accelerate cryptographic functions with this agreed upon set, which I think is something critical for this community and this ecosystem of partners. The next example I would give you is one of transaction protocols as well. I'm sure some of you are developers in the community, if not, or sitting in the audience. A smart contract execution engine today is dependent on the underlying distributed ledger that runs it. For example, chain code runs on Hyperledger Fabric, EVM runs on Ethereum, and I already talked to you about JVMs running on R3. Wouldn't it be great if the developers could choose their smart contract execution engine irrespective of the distributed ledger that's actually running it, right? That's the promise of Hyperledger Transact. The ability, they are currently starting and defining requirements to support Hyperledger Fabric and Hyperledger Sawtooth, but the architecture and the design is expected to include other distributed ledgers in the future. And Transact will deliver this common SDK to really support that. So the vision of Hyperledger Transact is a developer doesn't have to worry about, they can write their smart contract in one environment without having to worry about which distributed ledger it's actually going to run in, okay? Which is pretty powerful in my opinion. So the things that you see on the slide are really, the developers have the choice. They're not locked into one blockchain infrastructure over another, and there is ability for them to implement this across multiple distributed ledger frameworks. Let me move to software. Intel gives developers the opportunities to write directly to our silicon primitives or take advantage of contributions that Intel is making to the open source community. Last year, in this forum, there was a proof of concept announced between the Tel Aviv Stock Exchange, the Floor, and Accenture around securities lending. And the intent of that project was really to minimize fragmentation and minimize or accelerate the growth of that. And I want to give you a progress report on where we are at. The platform developed for that is called Securities Lending, and it provides on-chain confidentiality that uses Intel SGX and Hyperledger Sawtooth, where encryption and decryption of transactions actually happen on-chain. And the advantage of that really is that there is data confidentiality, and with the addition of Raft, you get transaction finality to that infrastructure. That project successfully finished its POC. It's moving into pilot, and they're looking for additional network participants to take advantage of that. Now let me bring this all together using these three pillars of silicon, standards, and software, and give you an example that builds on that transaction, on that, on the trust that the foundation of trust that I talked to you about, of security, privacy, and deployability, and give you an example which I think is extremely powerful. The Trusted Compute specification reached 1.0 status earlier this year. And the promise of the trusted execution of the Trusted Compute specification, it allows a developer to perform transactions on-prem or in the cloud off the shared ledger. So you perform that transaction off the shared ledger, but you post the results of that transaction back to the main ledger. So it gives developers two basic advantages. The first one is you can take dedicated compute power off the main ledger to perform your complex transactions, but still take advantage of the computational trust that a blockchain provides you. As you can see, this improves transaction throughput because you can do these transactions very quickly in these dedicated compute nodes. It improves privacy, and I'll tell you how it improves privacy on the next slide. And it lessens the data overload on the shared network. So let me tell you how this actually works. So the use of the trusted execution environment, whatever that may be, really helps the developer to decide that the workload that they want to run off-chain is actually performed by the compute engine that they so designated. So that's number one. And the trusted execution environment also helps validate the results of that execution when it gets posted back to the main chain. So because of the use of the trusted execution environment, you're able to maintain privacy of the transaction that was done. And you also take advantage of the computational trust extending all the way from on-chain to off-chain and obviously back. And you can do this in a way that preserves privacy. So you get the fact that you get computational trust, you get speed of execution, and you do that in a privacy-preserving manner is extremely powerful at the end of the day for the ecosystem. And this approach itself lends to more scalable and deployable options. Intel, along with iExec and other developers, are starting a new project in Hyperledger Labs where they will do open source code contributions as reference code in support of this specification. Okay? In closing, what I would say is Intel is working and continuing to work with the industry to enable business transformations and really increase, I should say decrease the time to value of blockchain deployments. We're committed to being a catalyst for blockchain. We're innovating in software, standards, and silicon, obviously. How can I forget silicon? And we are collaborating with the entire industry. That's what I'm here to tell you about. If there is something I want you to take, it's really these three commitments, along with the areas that I described to you, that Intel is contributing and supporting the advance of blockchain. So with that, on behalf of Intel, thank you for inviting us to this wonderful forum. Jacob, thank you again, and I hope you have a wonderful time at Cyber Week. Thank you.